We now start the matrix operations book, and we will do few chapters here and then go back to the differential equation book. So the first chapter in this book is about matrices. So what are matrices? What are the operations we can do with matrices, and how these will be helping us, solving problems in the differential equations. So a matrix, whose plural is matrices, is a rectangular array of elements arranged in horizontal rows and vertical columns. And usually we put brackets around these, arrangement. And in some books there are other notations as well, but we are using the brackets. Now the elements or the entries in a matrix can be numbers, it can be real numbers, complex numbers, or can be functions. And of course there can be other things, but the matrices that we will encounter in our course, we will have numbers or real numbers or functions in there. Now the notation for the matrices in this book, in the matrix operations book, we have used, the book has used the uppercase letters with bold faced, and we can also use lowercase letters with bold faced. Those are special matrices, those are called vectors. But the uppercase matrices, uppercase letters, I will use not the bold one. In most books we use just the uppercase letter, not make it bold as the name for a matrix. Now there is a size of a matrix or order of matrix. So here are some matrices represented with numbers and functions in the elements. So we have first matrix A. So it has 1 and -3 in the first row. So note how we put like a gap between the numbers to show that this is in the first column, second column, and so on. We don't put commas or anything in between. We just leave some space. So the first, the one here is we call it the first entry of the first row and the first column. So we can denote it by A sub 1 1. So in general we can call it A sub 1 1. So we are using the same letter as the name of the matrix, but lowercase. And this -3 is, if you note, is the entry in the first row and the second column. So we can call it A sub 1 2. So this is the entry of the first row and the second column. Now we go to 0. So 0, if you note, is in the second row and the first column. So this entry can be called A 2 1. And in the same way, the 5 can be called as A 2 2. So this is how, and in general, we write the matrix. So like in the same way, like the entries of B here, 0.5 can be denoted by little b 1 1. And the sign of T can be called little b 1 2. And this function T plus 1 can be called little b 1 3. So always we put the number of rows first and then the number of columns. And that also gives us the order of the size of the matrix. So for example, the A matrix is of order 2 by 2. So we write it like this. Its order is 2 by 2. And the B matrix, if you note, has 2 rows, 3 columns, so it is order 2 by 3. And the matrix C has only 1 row and it has 3 entries or 3 columns. So we say its order is 1 by 3. So always remember that the size of matrix, when you consider size of the matrix or the order of the matrix, you always have to say the number of rows first and then the number of columns. So in general, here we have a matrix A with m rows, because 1, 2, 3, 4, we go downwards, we end up at m. So m rows, and look here, this is n. So n columns, but there is an extra column here. So this is the n plus 1th column. So this is usually, we write it as an augmented matrix. We call it augmented because you will see, note later on, we often put a vertical line between these this matrix on the left and this column matrix on the right with the B's. This is called augmented matrix. So augment means to attach something, to attach one thing to another, and so we are kind of attaching another matrix which has entries B1, B2, B3 up to so on with the matrix on the left side. Now if we exclude this B and only keep the matrix here, this matrix, then this is actually A. Now this one is actually A augmented with B. So in short, a matrix can also be represented like this, where you can mention what is the size of the matrix, so it can be expanded that way. Now two matrices are equal if and only if the first thing, their size must be the same, and the second is that each corresponding entry must be the same. What is the transpose of a matrix? The transpose of a matrix A will be denoted by A raised to the power of uppercase T, and it is obtained by exchanging the rows and columns. So here we have A matrix. We note that there are 2 rows and 3 columns. So when we make the columns the rows and the rows become the column, then its order will reverse. So this is of order 2 by 3. The A transpose will be of order 3 by 2, and which is what we are seeing here. So the first column 1, 7 becomes the first row here, and the order the second column 3, 0 becomes the second row, and the third column negative 2, 1 becomes the third row. So what is a square matrix? Now by the name you can I think imagine a square matrix will be where the number of rows and number of columns are the same. Okay, so for example here A, the order of the matrix is 2 by 2. So this is a square matrix. The B matrix is of order 3 by 3, so it is a square matrix. What is a diagonal matrix? So it is a matrix, by the way, so when we have the square matrix, we can talk about the diagonal of the matrix. So it will be, there are 2 diagonals. So one is going like this. You remember in a square there are 2 diagonals. So if I draw a square, then I have one diagonal going like this and another diagonal like this. So if I look at this diagonal, this is a diagonal. So normally we will count this, and then we have another diagonal like this. Similarly, in the B matrix, you can see the diagonal. Now the diagonal matrix, the name diagonal matrix, is the one which has entries only on the diagonal, main diagonal. The entries are, which means this one going this way. So the entries are non-zero. All the other entries should be 0. Now on the main diagonal, at least one entry should be non-zero. It is not necessary that each and every entry must be non-zero. There could be some zero entries, but at least one entry on the diagonal, main diagonal, should be non-zero. Then we call it a diagonal matrix. So for example, down here, A has entries on the main diagonal. All of them are non-zero, so this is a diagonal matrix. But in B matrix we have 5, 0, 3. These are our entries on the main diagonal, and we see that there is 1 0 entry and 2 are non-zero, so it's still, we call it a diagonal matrix. Now, as I mentioned earlier, so the matrices which have the order n by 1, so means there are n rows and only one column, then that are called vectors, column vectors. And then also we can have row vectors, so which will be of size 1 by n. So there will be only one row and n columns. Okay, so we use again bold-faced letters for denoting the vectors. And in the book they use bold letters, but when we are writing, we either use an arrow or a bar on top of the letter, because it's hard to make a bold-faced letter when we are writing. Actually, it takes up much more time to make it bold. So here are some examples of vectors. So what is a zero matrix? A zero matrix will be an m by n matrix. So it can be of any order, whichever is suitable in the problem, but it will be a matrix which will have each and every entry equal to 0. So here is a matrix O. Well, zero matrix is often denoted by O and uppercase O, and it will have all 0 entries. Now it doesn't say or tell us what is the size, but it depends on as I said, what is being used in the problem. Okay, the next thing is a dot product of the matrices. So we often talk of dot product of vectors. We don't have a dot product of matrices. This is dot product of the column or the row matrices, not the other matrices. But so if A and B are of the same order, so we denote the dot product as A, the vector A dot vector B. That's why it's called a dot product. We put a dot in between, and this is obtained by multiplying the corresponding entries of the two vectors and then adding all of them. So for example, here if we have A, B and C, so if I want to find A dot B, A dot B, it will be equal to Okay, I will stop here and we will continue in the second video. It's taking too long to upload.